Hello world, welcome to the SkyRadar video channel, and let's have a look at the new FreeScopes version 7. I already placed 2 blocks here. We read a signal from the server, and this, I could alternatively also record from pre-recorded files, and then I transfer that to raw data. Now let's do the following. Let's start step by step converting and adding some features. For instance, let me just put here to that raw data the first A-scope so that we simply see what's happening. And the bigger your screen, the better. You might even drag your browser window over several screens, because you can place as many scopes as you want. You can even drag up and down the whole thing so that you place more scopes below and increase here the canvas where you place your blocks. Now let's suppress that source here because it's annoying us. You know, the reflection of the source is always the first peak that we see. So let's suppress that. And we could either, take the A-scope and connect it to that, but I think it's much more interesting to add another A-scope and just look at how it looks now. So, technically, it's not gone yet. So, let me click on suppress source. You see here we've got a property window. Look at this here. If I drag the suppressed source up to 1 meter 1, we should be pretty much covering it. There you go. That's nice. So you see, what's happening here is the A-scope is auto-adapting in terms of scale, and so these small peaks, which were pretty small here, get bigger. So I could even, in order to get this here a little bit more calm, I could, for instance, let me just limit it to 1. It's a bit too big. Let's go to 0.5. Oh, that's nice, huh? Okay. By the way, here you see volt because the A-scope technically shows volt, because what happens actually is we get the echo power, which arrives at the sensor, and that power is then measured. Power is, do you remember from school, U squared divided by the impedance. So if I take the square root of U square, I get to the voltage here. So we can make this smaller to get a little bit more space. For the interesting stuff. So what shall we do now? We could, for instance, take CFAR. CFAR, so we dynamically adapt the threshold to get rid of the noise. Here, the small noise. You know what I could do is, I could also get rid of the noise statically by, for instance, setting here a static threshold to, let's say, 0.1. You see that? So we filter out everything that is below that threshold. This is dangerous because you might have close or small targets which get lost through that. So we want to see all the targets. So that's nice. So looking at the properties of CFAR, I can change the alpha value, I can change the guard, the number of guard cells, I can change the window size. You know, there's several articles in our blog section about CFAR. Look at it, because then you will learn how this actually works. But I don't want to bore you. I mean, there's two people walking along, so let's see how they look in the PPI. We should see them. Here's the PPI. And let's add the PPI here. Now it's building up. I could in addition here set threshold. I can change the max range, the contrast. So there's two people walking, I mean my colleagues walking in front of the radar, which is absolutely safe because our beaming power is smaller than that of a mobile phone. And we're working at 8 gigahertz. 8 gigahertz doesn't penetrate the human skin. So this is something that is definitely great for working in a room in classrooms. What you see here is a much more complex block diagram. What I've done is, around the MTI, I put before the MTI an A scope and a PPI. After it, also an A scope and a PPI. You see here, after the MTI, we just see my colleague Iman, who is standing there and shaking a metal plate and then starting to walk around. Yeah. Here in the basic raw signal display of the radar image, we see, you know, the walls of the small room where my colleague was doing the recordings and some noise. So that's all cleaned here. We see just his movement. And here now, look, I took after the MTI, I went from a vector consideration and a matrix consideration. We do that with that burst block. We apply the Blackman window, FFT, CFAR, and then we start plotting and tracking, and then put that to the PPI. In order to see where I am, you know, I also added the raw signal so that we see the background. You see, I took the room here in a range up to 2.80 meters so that I get rid of the walls and I just see the movement of Iman. So he's moving. We see his history dots. And we see the arrow indicating the direction that he's walking to. And this is pretty much what you see in an ATC screen, you know. You see the aircrafts moving in the sky, the history dots, and the arrow showing the direction and the speed. But what is this here? You know, we've got another dot coming from that strong part of the wall here. What you see there is an interesting thing. It's the reflection of the Doppler frequency caused by the rotation of our antenna. This is something we'll eliminate in later courses, or in your earlier courses if you want to get rid of this. Just measure outside and not in small rooms where there is not so strong reflections close to your source. But I think the lesson learned here is really how we clean a radar signal from just something static, you know, in terms of, well, we filter a bit but not so much, to, hey, let's only look at the moving objects, to, hey, let's put the environment in the background with the unfiltered video image, and then let's put the plots on it. And now my colleague Iman is leaving the PPI, and I think that's good enough for today.